Welcome to the e-content on the topic Java AWT Building Graphical User Interface. This video presented by Dr. R. Pushpavalli, Assistant Professor, PG and Research Department of Computer Science, Sri Sharda College for Women, Autonomous, Salem. This lecture covers the following topics: Introduction to Java AWT, AWT Architecture, AWT GUI Components, Layout Manager, Graphics and Drawings, and AWT Multi-threading, Practical Examples, and Conclusion. Let's see the Introduction to Java AWT. AWT means Abstract Window Toolkit. The Abstract Window Toolkit, which was developed by Sun Microsystems in the early 1990s, being one of the first Java library for supporting the graphical user interface. AWT provides a set of API for creating user interface components such as buttons, windows, and menu, enabling the cross-platform GUI development in Java. AWT and Swing are two Java libraries used for creating graphical user interface in Java. The AWT classes are contained in a single library file named as a java.awt package. Swing is another one Java library file which also support to the graphical user interface, which built on the top of the AWT and provides a more comprehensive set of GUI components and features. Swing is a good choice for complex GUI that requires a wide range of components and customizing options, which also support to a cross-platform application. Here, the AWT hierarchy is given in a chart. Here, n number of benefits available by using AWT. AWT is built on the top of the core Java programming and using Java syntax and semantics. It is a part of a Java Standard Edition and is used to create GUI applications that run on the desktop. AWT offers directly access to native GUI components, making it efficient for applications requiring system level integration and cross-platform functionalities. The main reasons are platform independent, simple and easy to use, supporting the built-in supports available, lightweighted development. It also supports the event-driven program. Here, limitation: AWT is flexible and often less visually appealing than newer library like Swing, limiting customization options and advanced GUI features. Here, by use this AWT in some special kind of program only, small scale applications, prototyping, legacy applications, simple GUI programs were easily developed by use the AWT. Comparing the AWT with Swing, while AWT leverages native components, Swing is built entirely in Java, providing a rich set of components and better controls over the look and feel of applications. Now we have to see the AWT architecture. The component classes, container classes and layout managers are the core components comes under the AWT architecture. The component classes serves as the foundation for all visual elements in AWT, providing essential properties and methods for rendering and interactions. The container classes manage a collections of components, allowing for grouping and hierarchical organization, essential for creating a complex user interfaces. Finally, the layout managers determine the size and position of the components within a container, providing flexibility and adaptability to various screen size and dimensions. The following figure shows the class hierarchy for panel and frame components. A container is like a screen wherein we are placing the components like button, text field, checkbox, list box and combo box, etc. In short, a container contains and controls the layout of the component. A container itself is a component, thus we can add a container inside the container. Window. An instance of a window class has no border and no title. Dialog class has a border and a title. The panel does not contain the title bar, menu bar or border. It is a genetic container for holding the components. Frame. Frame has a title, border and a menu bar. It can contain several components like buttons, text field, scroll bar, bullets, checkbox, list button, other button, etc. This is the most widely used container while developing an application in AWT. Adding and removing controls. We need to add a components into the container. That time we call the function, that is method ADD. We need to remove any component from the container. That time we call the remove method. Sometimes we need to remove all the components from the particular container. That time we use remove all method. Here some constructors are listed to create a JPanel with a flow layout and a specific layout manager. Some other commonly used functions of JPanel also given. ADD component helps to create or add a components to the specific container. Set layout helps to set the layout of the container to the specific layout manager. Update UI, get UI and get accessible context are some other commonly used functions of the JPanel. Here a sample program is given to create a JPanel by using Java Swing library. Here create a new frame to store the text field and buttons, the named as F. Creating a label to display the text. That time we have to create a new object under the J label category. The B, B1, B2, B3 are the variables to create a new buttons. Here JPanel type we have to declare a object P in the type of JPanel. P.setLayout method helps to arranging of buttons in a manner of x-axis or y-axis. Here the main Java program to create a JPanel with a box of layout and adding the components to it. For that we need to import three different Java libraries: java.awt, java.awt.event, javax.swing. Then the class we have to create and extend from the JFrame. Here the variable JFrame variable and button variable and the label variable we have to declare as a static. Here p.add is the method that helps to add the buttons into the panel. P.setBackground helps to change the panel color. Adding the panel to the frame, that time we have to make use of f.adt. Within bracket we mention the p. P is a panel object. Then p.setSize. Set size helps to set or reset the window size. F.show helps to visibility of the panel. Event handling. Events in a Java can be broadly classified into two categories based on how they are generated. They are foreground events and background events. Foreground events are the events that require the user interactions to generate it. For example of the events included button clicks, scrolling the scroll bar, moving the cursor. And then background event does not request interaction of users to generate are known as the background events. For example, these events are operating system failure or interrupts operation completion, etc. Event handling mechanism that allows the program to control events and define what should happen when an event occurs. Java uses the delegation event model to handle the events. This model consists of two main components, source and listener. Events are generated from the source. There are various sources like button, checkbox, list, menu item, choice and scroll bar, etc. Listener are used to handle the events generated from the source. Each of these listeners response interface that are responsible for handling the events. Events adapter and event listener are two related concepts in a Java event handling. Event listener is an interface that defines methods for handling the specific events, such as button click or keyboard input. Event listener are used to respond to event generated by the GUI component. Event adapter is a class that implement an event listener interface and provide default implementation for all the methods. Event adapters are used to simplify the process of handling event by allowing you to override only the method you are not interested in. Here the different event and its source component and its relevant listeners are listed in the table. Here one of the example program is given for action listener to handle the buttons. For that we need to import two different libraries more. Import.java.awt.event.action event, import.java.awt.event action listener, and the following code we have to execute in your lab exercise. In the main, this code is the example of using mouse adapter to handle the mouse event. Here we have to import the java.awt.event.mouse adapter and event.mouse events. This code also you have to practice in your lab. Now we enter into the AWT GUI components. Button, label, checkbox, choice, list box and combo box, scroll box, text editor window, those are comes under the common AWT controls. See, these are the AWT components. Java Swing is supported to some advanced components like menu, dialogues and canvases. Menu are the list-based components that group related commands, allowing user to navigate and access the different functionalities of an application efficiently. Dialogues are pop-up windows that requires user interaction before processing, often used for alert confirmations or generating the information through the forms. Canvases provides a drawing area for custom graphics and shapes, enabling the developers to create advanced visual interfaces and interactive content within the application. Next, we focus on the AWT Layout Manager. In Java, AWT Layout Manager are used to control the arrangement of the component within a container. They automatically handle the sizing and positioning of the components, making it easier to create user interfaces and adapt to different screen size and resolutions. The AWT package provides a several built-in layout manager. Flow layout, border layout, grid layout, card layout and grid bag layout are the following layout managers. Here the flow layout manager is a default layout manager for panel and applet. It arranges the components in a row following to the next row if there is not enough space. border layout divided, which helps to manage the divide the container into a 5 region, north, south, east, west and center. Each region can hold one component. The grid layout manager arrange the components in a grid of row and column. All cells in the grid have the same size. Card layout. This layout manager allows multiple components to share the same space with only one component visual at a time. It treats each component as a card in the stack. Finally, the grid bag layout. This is the most flexible layout manager, allowing for example layouts with components of varying size and position. It uses a grid of the cell, but component can span multiple cells and have different weights and fill directions. Sample grid layout is given in this screen. Grid layout is a layout manager in Java that arranges the components in a grid of rows and columns. Here 5 different buttons used as a component which contains in a container. All the components make in a same size. Now we move to the AWT graphics and drawing. Java provides a range of classes and methods for creating graphics and performing the drawing operations. Graphics classes is the base class for all the graphic context. It provides a method for drawing shapes, text and images. Graphics 2D class extended the graphics class and provide the additional method for drawing and manipulating the graphics. Here some methods are given for drawing purpose. Draw line helps to draw the line between 2 points. Draw rect method helps to draw a rectangle. Draw oval method helps to draw a oval shapes. And draw string, draw a string of the text. Draw image helps to draw an image or import an image on the canvas. Here another one Java example program is given for graphics and drawing. You should do this exercise in your lab. AWT multithreading. The single-threaded and multi-threaded programming are two approaches to handle the task in AWT applications. Single-threaded programming, all tasks are performed by a single thread, known as the event dispatch thread. The event dispatch thread is responsible for handling the GUI events, updating the GUI, and performing other tasks. The main advantages are using single-thread programming. Single-threaded programming is simpler because you don't need to worry about thread safety and synchronization. Single-threaded programming has a less overhead because you don't need to create and manage the multiple threads. In multi-threaded programming, multiple threads are used to perform the different tasks. This approach can improve the responsiveness and performance of your application. The main advantage of the multi-threaded programming are responsiveness of GUI. Multi-threaded program can keep the GUI responsive even when performing a long-running task. Next one, improve the performance. Multi-threaded programming can improve the performance of your application by utilizing the multi-CPU core. Conclusion and future of AWT. In conclusion, AWT's architecture provides a foundation for creating the GUI application in Java, but it has some limitation. While it may still be used in creating context, more modern GUI libraries like Swing and Java FX offers more features and flexible. Thank you.